All right, this is the fifth number. We have logarithm of brackets 4 roots. That's fourth root of 4. This is 4. Fourth root of 4 into bracket third root of 4 close bracket to base 4. Now, looking at this bracket here simply implies multiplication, whereby we now have, since this is multiplication, looking at this, what we have here is 4, and what we have here is 4. Now, referring to laws of indices, where we treated about fractional index law and which involve this root, we said that this 4 here is something with this root here means, this fourth root means 1 over 4, and then this third root means 1 over 3. Okay, now the 4 here is for this 4, the 3 here is for this 3. Now, at this point, now that we have the basis the same, we can now apply multiplication law of indices. Multiplication law, whereby we take one of the bases, and the reason why we are following this method is because our target is to make sure we have 4 and 4. That's for logarithm of 4 to base 4, which will end up giving us 1. Okay, now progressively we have 4 times 4. Okay, now we take one of the bases, which is 4, and then add up the powers. We now have 1 over 4. Because of times, we now say plus 1 over 4. 1 over 3. Okay, now we now say 1 over 4 plus 1 over 3 will give us 7 over 12. Okay, you can follow your that's LCM of 3 and 4 and 3 is equals to 12. 4 into 12 is equals to 3, which is 3. That 3 times 1 is equal to 3. Now 3 into 12 is 4. 4 times 1 is 4. So that 3 plus this 4 will give us 7. Okay, that's 7 over 12. All right. Now that we have the same number with the base, we now from the power law of logarithm, the power multiplies the log. That is, this 7 over 12 multiplies this log. We now have 7 over 12 log 4 base 4, and of course log 4 base 4 is equals to 1. Okay, now we now have 7 over 12 times 1 equals to 7 over 12. That is it for this one. Now the sixth question says, if log s base 10 is equals to b, what is 10 raised to the power 2b? Now in this case, looking at 10 raised to the power 2b, you ask yourself, how can we actually get 10 raised to the power 2b from here? Now if you watch from the first video where I taught about definition of logarithm, I explained this. Okay, now logarithm converted to index form is this. So this thing now is something with this. The base takes up this b as power equated to this number of base. Okay, now since that's the case, if you look at it, this 10 raised to the power b is almost looking like this. The only difference is that there's no 2 here. So once you multiply this b by this 2, it will give you the same thing with this. In other words, multiply this power by 2 and also give this one its own power of 2. So we have power of 2 here. That's then 10 raised to the power 2b equals to s squared. Okay. Now, in other words, 10 raised to the power 2b is equal to s squared. In other words, we mean if log s base 10 equal to b, therefore 10 raised to the power 2b is equals to s squared. All right. Now, in this case, we have 7, and there's nothing more to work here because we have gotten what we are looking for. What is actually the value of 10 raised to the power 2b if we have this? So here, number 7 says 2 minus log s. Now, 2, in this case, we have to look for a way to make this into have something in this one to have something in common with this. Having something in common, since we cannot solve this one like that just directly, except when we are given special logarithm numbers like logarithm 2, logarithm 3, logarithm 7. Okay, but in this case, there's nothing like that. Here we have to work on 2 and also work on 5. Here we have logarithm. In this question, we are told strictly to solve without table. So we are not going to follow that other method of logarithm 2, 3, and 4, and 7. Sorry. Now 2 is same thing with logarithm 100. Okay. Now it's same thing with, this is having a visible 10 here. When there's no base, it's having. We assume it is in base 10. Now the 10 raised to the power 2 will give us 100. That 2 multiplies this. So logarithm of 10 base 10 will give equals to 1. So 2 times 1 will give us. You can watch the other videos to get more grounded in this. So logarithm 2 is equal to logarithm 10, logarithm 100. Now minus log 5. Now we factor out the log. Common thing here is log 10, log 10. So factor out the log of base 10. We now have 10. Because we have factored out the log, this minus becomes division. This 5 comes in. Now we now have logarithm of 100 over 5 is equals to 100 logarithm of 20. So that's it for this one. Now look at the other problem. We have 8 question. Logarithm of 2 base 4 minus logarithm of 0.25 base 4 plus logarithm of 16 base 4. Now in this case, if you watch very well, you find out that we have log base 4, log base 4, log base 4. So we can actually factor out log base 4 at a particular level of this solving. Now, but before then, this decimal should be converted to fraction. Now, converting this decimal to fraction, we have 25 is the significant number after decimal point. We put it all over 1. Now we move from decimal point 1, 2. So since we move 1, 2 times, we have 2 zeros after the 1. Now plus, this is still what it is. Now at this point, what we have here is, since we have logarithm of base 4, logarithm of base 4, logarithm of base 4, we have to factor out the logarithm of base 4, okay, into bracket 2 comes in. Because of minus, we now say divided. That's divided by 1 over 4. Now times, because of the plus, we now, the reason why I have 1 over 4 is because 25 into itself is 1, 25 into 200 is 4, okay. Now plus log, this one has been factored out, we have 16 left. So because of plus, we now say times 16, okay. That is it. Now we now have to solve what we have inside the bracket. Now this division, we have division. You have division after division. In other words, we have to work on this. Remove one of the divisions. So removing this division, change it to multiplication. We now inverse this. So 1 over 4 inverse will give us 4 over 1. Of course, 4 over 1 is equal to 4. Now times 16. So 2 times 4 times 16 will give us 128 to base 4. Now at this point, where we have log 128 base 4, we have to look for the real value for this. How do we do it? Like in the previous videos, we normally assign a variable. So assigning a variable, this base take this variable as power. Okay, that's 4 raised to the power x, 4 raised to the power s equals to 128. So at this point that we have this, we need to look for a way to make the base the same. The common base for this 4 and 128 is 2. So we now have 2 raised to the power 2 will give us 4, 2 raised to the power 7 will give us 128. Now, cancelling out the common base, we have to equate the power. We now have 2s equals to 7. Okay? So at this point, we now have s equals to, dividing both sides by quotient of s here. These two, when you divide this one by 2, the 2 will cancel the 2. And then we have 7 over 2, or 3, this 7 over 2 will give us 3 whole number 1 over 2. So 7 over 2, same to 3 whole number 1 over 2. Now at this point, we now have 4 log 3 base 3. Plus log 9 base 3 minus log 18 base 3. At this point, you find out that we have log base 3, log base 3, log base 3. But the only difference here is this 4. In other words, we have to remove this 4 from here. Removing this 4 from here means that we should take it back to power form. So, or rather, I think it's simpler in this form. Look at, we have log 3 base 3, that's 3 will give us 1. Logarithm of a number to its own base equals to 1. So this one is just gone, okay? As simple as that. We have plus log, this one, we have to look for a way to make it have the same number with same base, as the same thing with this one. Now this is going to give us 3 raised to the power 2 will give us 9. Okay, that's 3 raised to the power 2. And for this one, there's no number we cannot raise 3 to anything to give us 18. Okay, now in that case, we have to dissociate this. Look for the highest number that we can raise to power, the highest factor of 18 that we can raise to power, and that we can factor out the base that will give us this 3, okay, as the base, which is 9. Of course, 9 times 8, 9 times 2 will give us 18. Okay. Now at this point we have we have 18 log 9 times 2 base 3. So we have to separate them individually. We now have logarithm minus logarithm 9 log the 9 base 3. Because of times, we now put plus. We have to share them their logarithm so that they can stay. We can solve out this 9 and have this one left, since we cannot solve logarithm of 2 base 3. So we now have this times turned to plus. We now have log 2 base 3. Now we have log 4 plus 2 times 1. Of course, logarithm of a number to its own base equals to 1. Then minus, this is still what we have here, okay? The only difference is that we now have to open up the bracket. Minus times this will give us this. Minus times this will give us minus this. So we now have 4 plus 2, that's 2 times 1 is 2, minus 9 will give us 3 raised to the power 2. Okay, we are progressing with this. So we now have these 2 we have to factor out. Okay, 4 plus 2 is equal to 6. Now 2 factoring out, we have 2 times log 3 base 3 minus log 2 base 3. Okay, we now have 6 minus 2. This is now 1. 3 logarithm of number to its own base equals to 1. So we now have 2 times 1. Now minus log 2 base 3. Now equals to 6 minus 2 minus log 2 base 3. Of course, this is now 4. 6 minus 2 will give us 4 minus log 2 base 3. In this case, there's nothing we can do about it. So the thing will be left as it is. All right. Now, question number 10. We have 3 log 16 base 8 minus log 1 to 8 base 8. Now, at this point, we find out that the common thing here is just log 8. So we can look for a way to have log 8 factored out. So in other words, this 3 has to come out from here. This 3 coming out, we have like 16 raised to the power 3 minus this one is just the way it is. Okay, now 16 raised to the power 3 is equal to 4096. Now minus log 1 to 8 base 8. Now that we have log 8, we have to factor out log 8. We now have 4096. Now because of minus, we now say divided. Now divided by 1 to 8. Now this divided by this will give us 32. Now for this one, we cannot make the base the same. Since we cannot equate it to s and solve it as ordinary logarithm, convert to indices. Now we now have equal to, we just equated to s, so that the value of s will be the value for this logarithm of 32 base 8. So we now have this from from definition of logarithm. This base take this variable as power, equated this number. Okay. Now we look for a way to make the base the same. Of course, the common base will be 2. So 2 raised to the power 3 will give us 8. 2 raised to the power 5 will give us 32. And then, since the bases are the same here, we can cancel out the bases and equate the power. So we now have 3s equals to 5. Now, 3s equals to 5 implies that x is equals to 5 over, dividing both sides by quotient of s here. 3 will cancel 3. This 1 over 3 will give us this. So this is same thing with, how many 3 are in 5? 1. Remainder 2 over this same 3. Okay. Now, the 11th question is 2 log 5 plus 2 log 6 minus 2 log 3. Now, if you look at this, you find that the common thing here is just 2 log. So we factor out the 2 log into bracket 5. Because of plus, we now say times this 6. Because of minus, we say divided by 3. So we now have 2 log 5 times 6 is equals to 30. 30 divided by 3 is equal to 10. So we have 2 log 10. Okay? And of course, you know that this is not having a base here. So and when base is not given, it is assumed that we are dealing with base 10. So we bring in the base 10 here. Now logarithm of number to its own base is equals to 1. So 2 times 1 is equals to 2. That is it for this question. So question number 12 says 2 log 5 plus log 72 minus log 18. So we now have logarithm of, now if you follow what's critically here, we find out that we have log and 2 log. So the only difference between this one and this other one is these 2. So we have to remove these 2 from here. Removing these 2, it comes out as power. Okay, so every other 10 is now normal. So the reason why we do this is for us to be able to factor out the common log. Now factoring out the common log, we have 5 raised to the power 2 is 25. Because of plus, we now say times. Now we have 72 here. Because of minus, we now put division. Then we have 18. Now implying 25 times 72 over 18 will give us 100. And logarithm of, we know that this is having automatic, logarithm of 100 is equal to 2. But let me just break it down. This is having automatic 10 here. When the base is not given, it's having 10. Okay, we now have logarithm of 100 base 10. Now we now have, since we now equate x and solve it out as indices. So we have 10 raised to the power s equals to this 100. Okay, now we have to make the base the same. Now 100 is same to 10 raised to the power 2. Now that the bases are the same, we cancel out the bases and equate power. So x is equal to 2. Therefore, this log is equal to 2. Now, the 13th question says, if log s base 2 plus log s base 8 plus log s base 32 equal to 46 over 5, find s. Now, we now say, in this case, this will be very long for us to solve with carrying this one along. So, I now focus on the left-hand side. Now, considering the left-hand side, now this is the left-hand side here, this side of the equation. This is the right-hand side. Okay, now, this is, solving with this now, we find out that this there's no way we can, the numbers are the same, but the bases are not the same. Now that there's no way we can factor out anything here. We cannot factor out just log without the base, without the base. Now that is in this case, what we have to do is to apply by base changing law, which we treated in second video of this logarithm. Now we have logarithm of s to base 2. Under base changing law, we make sure that all of them have the same base, and it is advisable for all of them to have common base 2, the smallest base. Now, having this one, when you change the base for all of them, the division side will have these 2 as its number. The division side, this one will become log 2 base s. This one will also become log 2 base s on the upper part. This one will become log 2 base s on the upper part. And here will also be, log base s, not base s, log s base 2, log s base 2, log s base 2. Now here will now be log 2 base 2. That the common base for all of them is that 2. Now down here will be log 8 base 2. Here will be log 32 base 2. So all of them is now having base 2 base 2. Now that is in this case, we find that there is likely to be something in common. Okay, so since there's no, okay, so this is the continuation of the video, and now we have logarithm of 2 to its own base equals to 1. Logarithm of this is 3, this is 8 here. We have to make the base the same. Now making the base to have the same value with the figure here, with the number here, 8 is same to 2 raised to the power 3. How can we get 2 here? We say 2 raised to the power 5 will give us 2. So at this point we now have to apply the power law. 3 multiplies this, 5 multiplies this, okay? So we now have 2, 2, 2, 2. And of course, logarithm of a number to its own base equals to 1. Logarithm of a number to its own base equals to 1. Now we now have logarithm of s base 2 all over 1. 3 times 1 is 3. 5 times 1 is 5. Now at this point, having this fraction with plus, whether you have plus or minus, what you have to do is apply LCM. Okay, so LCM of 3 and 5 is equal to 15. Now 5 into 15 into 1 divided 15 divided by 1 is equal to 15. 15 times this is equal to 15 log s base 2. Now 3 divide 15 will give us 5. 5 times this will give us 5 log s base 2. That's 5 log s base 2. Now 5 divided 15 will give us 3. 3 times this will give us 3 log s base 2. Okay. Now at this point we now have 15 plus 5 will give us 20. 20 plus 3 will give us 23. That's 23 s log 2. This log s log 2 log s base 2 is what we have in all of them. So we have 23 log s base 2 all over this 15. Now, since we have done this and there's nothing more to cancel out here, this is just the way it is. We can remember that we had this this equation of 46 over 5. So we bring in that this left-hand side, of course, is equal to 46 over 5. So we have 23 log s base 2 over 15 equal to 46 over 5. Now at this point, what we have to do when we have fraction and equation is just to cross multiply. So 5 times 6 will give us 115 log s base 2, and 15 times 46 will give us 690. Okay. Now at this point we need to have this one alone. So for us to have log s base 2 stand alone, of course our target is s, so we have to make sure that everything about s stays to this other side. Now we have to divide both sides by the quotient of this log s base 2, which is 115. Now dividing both sides everything by 115, we have 690 divided by 115 give us 6. So at this point we have this is same to it. I change this to index form. We have 2 raised to the power 6 will give us s, and then s is equal to 2 raised to the power 6, of course, is equal to 64. That's it for this quiz.